Hello, today's lesson is over section 7.4 of the book, Properties of Logarithms. And there's three main properties that we're going to talk about today. They're called the product property, the quotient property, and the power property. Okay? So all these have to do with terms of logarithms. And if we look at the first one, the product property, it says log base b of m times n. So this is why it's the product property, because m times n. We can rewrite it as log base b of m plus log base b of n. Okay? Then we go to the quotient property. We have log base b of m divided by n. So it's the opposite of what we did up here. This is multiplication, this is division. With multiplication we add, and division we subtract the two. So log base b of m divided by n is equal to log base b of m minus log base b of n. And then lastly we have the power property. We have log base b of m to the power of n, some number. And one of the properties, this is one of the big things that logarithms help us out with, we can take this exponent and we can bring it to the front of the logarithm like this. So this n is now brought to the front and now is multiplied to this log base b of m. Alright, so here's our first example. We're trying to simplify the logarithms in this one, and we want to write each expression as a single logarithm. So notice we have an expression, and there's two terms that have logs in it. We want to simplify it down to only one term. So in order to do this, we use our properties of logarithms that we just talked about. So if we look at this, this is subtraction. So we can see that this is going to be the quotient property because that's the only one that deals with subtraction of two logarithms. And what that means is if we are subtracting the two logarithms, notice they have the same base. That's a key term right there, key point. But when we subtract these two, we divide. So we divide 32 divided by the 2. So we're going to take this number, and we're going to make a quotient out of it. So 32 divided by 2, and that will easily simplify to 16. So we have log base 4 of 16. Okay? So the next one, letter B. We have still the same thing. There's two separate terms with logarithms, and we want to simplify it down to 1. So let's look at this one. We have 6 times the log base 2 of x plus 5 times the log base 2 of y. We want to do something with these coefficients first. Now remember in the power property, if we had the exponent right here, we could bring it out in front. Well, the reverse is true also. So we can take what number is out in front and we can apply it to the exponent of the term that we're taking the log of. So we have log base 2 of x, and instead of multiplying it by 6 here, we're going to take this 6 and move it to the exponent. We're going to do the same thing with this 5 on the other logarithm expression. So y to the power of 5. Now we still have two logarithm terms. And what do you think this is going to be? Well, addition means the product property. So this means we're going to multiply the two terms together. So we have log base 2, and we have x to the power of 6 times y to the power of 5. And that's how we would simplify that expression. Alright, here are two problems that I would like for you to try on your own. Pause this video, and then when you get done with these two problems, go ahead and hit play, and then I will show you the solution. Okay, so you notice that we have two logarithms in each expression again, so we want to simplify it down. So we're also going to use the properties of logarithms again, so just those same three. So this one is addition, so that one has to be the product property. So that means with the same base, so log base 4, we can take that to the log base 4, and then we're going to just simply multiply the two terms. So 5x times 3x. Now we just do that. 5x times 3x will simplify to 15x squared. And there's my solution. Okay? Looking at B, again they have the same base, but notice we have coefficients again. So I'm going to take this and I need to move it to the power of 6. So I'm going to have log base 4 of 6 squared minus log base 4 of 9. Okay? Now there's two things that I can do at once here. Notice 6 squared. Well, that's 36. So I'm going to keep that there in mind. And then it's minus the log base 4 of 9. So this is the quotient property. So again, the quotient property means we have the same base and we can divide the two. So 6 squared is 36 divided by 9. And we know that we can simplify that into log base 4. 36 divided by 9 is 4. Now, anything with a base with the same number here, this is 4 to what power will give me 4? We can simplify that even further quite easily, and that would just be reduced to 1, because 4 to the power of 1, so this base to the power of 1 will give me 4. Right here, so here's example 2. So problem 2, expanding logarithms. So we want to try to expand each logarithm. Well, in example 1, we had an expanded logarithm expression and we simplified it down into 1 log. Sometimes it's good to be able to break it apart and see and evaluate each individual piece of it. So again, we're using the 3 properties of logarithms, and if we look at here, we have log, and we don't have a base of 4x divided by y. Now, if you remember, if we don't have the base shown, what is it? Well, it's the common logarithm, so it's log base 10 of 4x divided by y. So this is the quotient property, and remember that just means we take log base 10, same thing, of 4x minus the log of y. And that's really it. Now we could separate this as well. This is 4 times x, so we could say log of 4 plus log of x, because that's the product property, and remember you add in that one, and then the minus log of y. So again, remember this does have a base. Just because I'm not writing it doesn't mean there's not one. This is base 10. So let's look at b. We have log base 9 of x to the 4th divided by 729. Well, again, this makes a quotient, so this is the quotient property. Well, that tells us we're going to separate it. So log base 9, and we're going to say we're going to subtract both log expressions, 729. Now, we still have another property here. Remember, we have an exponent inside this logarithm, so this exponent of 4 we need to be able to take out in front. So we have 4 times the log base 9 of x minus log base 9 of 729. And there's our answers. And here's the got it for this section. So I want you guys to try these 2 problems. Expand each expression like I did in the previous example. Go ahead and pause the video and press play when you're done with it, and I'll show you the solution. Okay, so again, we have log base 3 of 250 divided by 37. Well, we know division is the quotient. So this is going to be the quotient property again. So we have log base 3, again we're not changing the base, of the top, the numerator, 250, minus the denominator. So log base 3 of 37. And that's it. That's all we had to do. So if we look at the second one, again, log base 3 of 9x to the power of 5. Now let's look at this. This has a few different things. This is 9 times x to the 5th. So this multiplication means that we can separate it as the product property. So log base 3 of 9 plus log base 3 of x to the 5th. Now we're not done with that, because remember, when we have an exponent in the logarithm, we want to take it to the front. So we're going to have log base 3 of 9 plus 5 times log base 3 of x. Okay, so here's an important formula for us to be able to evaluate logarithms, and it's called the change of base formula. Now, if we have log base b of m, sometimes it's hard to evaluate it for different bases and different logarithms. So we have this change of base formula, and this is something that helps us with the calculator, because remember, the calculator can only do log base 10, so only the common logarithms. So this c right here that you see in the calculator, you're just going to make that 10. Now, so we have log base b of m, and we can change the base to whatever base it is. If we have the same base in the numerator and denominator, that's going to be fine. So we have log base c of up top and in the bottom. Now, the term that we're taking the log of, this is going to be the top, the numerator, and the base becomes the term that's in the denominator. So log base b of m is equal to log base c of m divided by log base c of b. Alright, so here's the third example, the first one on the change of base formula. So we're going to use the change of base formula to help us evaluate this logarithm. So the way we do that is, again, we can pick any base, but there's two different methods that you can use sometimes. And the first one, this is going to be kind of how I taught class last time. So using a common base, and if you see that we have a multiple of 3, so 3 to the power of 3 is 27, 3 to the power of 4 is 81. So let's try to use that base of 3. So log base 3, log base 3. Now, remember, this term goes in the denominator, and the base goes in the basement of our fraction, or the denominator of the fraction. So it's going to be 27 up top, and then 81 in the denominator. So now this is saying 3 to what power will give me 27? Well, 3 times 3 is 9, times 3 again is 27. So this numerator reduces to 3. Now if we take that 27, 3 to the power of 3 is 27, and multiply it by 3 again, we should get 81, which that means 3 to the power of what equals 81? Well, that what is 4, so this should reduce to 3/4. Now, method 2, this is the method that I would prefer you guys use because this will always work. You can use the calculator. Well, I guess it'll always work unless you don't have a calculator. But if we look at this, log base 81 of 27, let's choose our base to be 10. So let's use the common logarithm so we can put it into the calculator. So now we have log base 10 up top and the bottom. I want to use red. Well, oh well. So log base 10, and remember, if the base is 10, we don't have to write it. So we're going to have log of 27 over the log of 81. And all you got to do now is plug that into your calculator, and you should get the same answer of 3/4. Alright, so here's the other goddess. So I want you to evaluate each expression using the change of base formula. Either way, if you find a method 1 or base to method 1, go ahead and do that. If you want to use the common logarithm in your calculators, that's fine as well. But go ahead and pause this video, and then once you're done with it, press play and I'll show you the solutions. Okay, so if we have log base 8 of 32, we've simplified this down into one expression. Think of another problem that we've done. So this is just one logarithmic expression. So we can use the change of base formula to evaluate it. So I'm going to say that we have log base 10 of 32, the common log, and then log base 8 of, or base 10 of 8. So if we put that into the calculator, we will get a decimal 1.66 repeating. Now we can change that if you hit the math button and enter twice. You can change it to a fraction, and that will change into 5/3. Alright, so now we look at the other one, log base 4 of 18. Again, if we use the common logarithms, we have log of 18 over the log of 4. And that will give us the answer 2.085. And so I rounded up to the third decimal point, the 1,000th decimal point, so it's 2.085.